So last time our discussion was about if we excite an ATI system with a holistic signal, we know how to get the output using the Fourier transform, and the output Fourier transform will be the input Fourier transform of the signal multiplied by the transfer function. This is a deterministic signal. If random signal, we don't know how to find the Fourier transform of the signal because it's random. Every time you run the system, you will end up with a new waveform. So you cannot have the Fourier transform of every waveform. And because of that, we said, okay, let's use the autocorrelation function, which gives us basically the relation how the signal and how the random process moves at on average, or basically how fast it is, which gives us how much frequencies exist in that signal. And taking the Fourier transform of the autocorrelation function will give us this power spectral density of the input signal. Multiplying this with the power transfer function or the magnitude square of the transfer function of the system will give us the output power spectral. Okay. Now, basically, it's very simple relationship. Now, what we'll do in the rest of this class is take some examples and then move to the statistics. I'll concept that. Right. So basically, here we have the transfer function or LTI system, and we gave you a transfer function. Okay. So if we take the magnitude square, it will be like this, and this is a typical LR filter. Resistor after that, so the resistor and the inductor. And we are taking the input from here, out from here. Okay, we have seen circuits like that in circuits and so on, right? So you can find the transfer function. Transfer function given by this. So the transfer function squared, magnitude squared, the power transfer function is given by this. Now, if I excite the system, so basically the output power spectral density will be the input multiplied by power transfer function or the magnitude squared. And if the input is white noise means it has a PSD of constant, right? So SXX omega is a constant at N not omega. Right, sure? So basically this multiplied by the magnitude squared will give us this. And if we would like to calculate the average power at the output, simply we need to integrate the PSD at the output from minus infinity, which will give us a naught R divided by 4. Right? So this is not what we have done in 207, except that the input is random, the rest is the same. You need to find the transfer function and take magnitude squared and then multiply the input PSD with the transfer function magnitude squared. Okay. Another example is when you have the input having the autocorrelation function given by this. It's a typical autocorrelation function that looks like this. So RXX. So basically it decays as tau increases. If we change 4 into 10, then how will this autocorrelation function look like? The 4 with the now 10. How this autocorrelation function will look like? No. So it will be having higher frequencies or less frequencies? Smaller frequencies. Now means what? Moves at a faster rate or smaller rate? Faster rate. So basically it contains higher frequencies. Exactly. If you take the Fourier transform of this, you will get basically something like this. Okay, so basically if this becomes narrow, this becomes wide, which means higher frequencies, higher band. Okay. Now, and basically give you this circuit. Now you need to find the output PSD. So if I give you a circuit, can you find the transfer function? This is the input, this is the output. Typical circuit question. وأنا راح أحكي لكم على السيركت وإذا بتفكر Okay, so this is not an exam about circuits. However, you need to be able to, you need to be comfortable finding the transfer of any circuit. So now, from here, basically, we find the transfer function as this. This is a transfer function. And if we simplify the transfer function, we'll get basically this. And the output PST will be the input PST multiplied by the transfer function magnitude square, which is the. And this is kind of, well, okay. ايش رايكم؟ ايش هذا الفكره؟ How do you see the picture? The output, the input واضح كيف شكله. هذا ايش عباره عن ايش؟ How can you describe this for me? Is it a low pass filter, high pass filter, band pass filter? Which one? It's not a low pass and not a high pass. It's not either one, band pass. It's a low pass. It's a low pass filter بس هيكون في بعض التغييرات في البند. اوكي لما تشوفوا دائما اوميجا يعني نفس الاوردر اوف اوميجا here and here means that it's usually order because it doesn't dump any frequency. يعني يكون لو تشيل اوميجا هذه معناها means as omega becomes higher لو هذه اوميجا شلناها as omega becomes higher ايش يصير magnitude becomes smaller, right? Which means a low pass. The high pass العكس. If we remove this omega means that I am giving higher wave to higher frequencies, right? The band pass لازم يكون في omega minus certain omega zero. So basically it's contained within certain frequencies. Fine. Shabab, any question? The example. Again, white noise. White noise, لما أقول white noise إيش يعني؟ What do you get out of white noise? USB is flat. Okay? So white noise على طول. SXX omega looks like this. واضح شباب؟ So white noise. And basically it's given by, and this is the autocorrelation function. So n naught over 2 is equal to kam? Equal to kam, what is the level of the PST? Into minus. طبعا هذا ال PST autocorrelation function looks like an impulse, right? With 10 to minus. So this is the autocorrelation function. Is applied to a network with impulse response given by this. So this is the impulse response of the LTI system. Okay. Find the network noise output power in a 10 ohm resistor. That's right. Yeah. So we need basically, if this is the input, so we have an LTI system here with an impulse response given by Addy. We have X of t. We are getting at the output Y of t. The question is, find the network noise output power. Output power means the power of X of t or the Y of t. Okay. How to find the power of Y of t? Exactly. Take the PST. We take the Fourier transform of this, multiplied by magnitude square by the PST of the input, and so basically you can say that the output PSD equals the input PSD multiplied by the power transfer function. Power transfer function, if we take the Fourier transform, this will get this, and we square it. Now taking the area under the curve, either by using the relationship اللي اتكلمنا عنها in that over 2 in the time domain or in the frequency domain, both should give you the same answer. Okay. Now, any question? So the summary of chapter 8, will be in a simple way. Summary of chapter 8. This equation, and basically the output spectral density equals the input spectral density multiplied by the power transfer function, and the relationship between the output mean and the input mean, and the output power and the input and the autocorrelation function, which is for white noise, it was given. So this is roughly the summary of chapter 8, what you need to know about chapter 8. API system with input response. Input is random with certain autocorrelation, certain mean, certain power spectral density. What is the output? The output mean equals the input mean multiplied by the area under the curve of the impulse response. The output power equals this double integral. And if you just write it for white noise, it will be the PSD level of the white noise multiplied by the area under the square of the. And the output PSD is equal to the input PSD multiplied by the power spectrum. These are things that we need to know about chapter 8, and the rest is what we need to do some practice. Examples as we have discussed in detail. Any questions about it? طبعا.
السؤال كان معطينا كلمة في لسه. هذه البيع كلمة في لسه عنوان.
Yeah, it will be different.
Very different, but what we will do, we will just divide the average power by all the register.
Yeah.
The average power. So we divide it by the resistor.
Only 1 ohm resistor.
Yeah.
Yeah, if you have a 2 ohm resistor, what do you do?
By the power, by the resistor.
This. Last question, or the example, is again white noise. With power density n naught over 2, not it can actually n naught over 2, 6 times 10 to minus 6 is applied to an ideal low pass filter with gain 1 and bandwidth W. Find W such that the output average noise power is 15. So I can give you the bandwidth and I ask you for finding the average power, or here is the opposite. So simply you just use the power spectrum. The average power is the integral or the area under the curve of what? What is this? SYY, right? Right. So basically you take the average power, so the area under the output PST, which is the input PST multiplied by the power transfer function. Now the input PST is a constant. The average, the transfer function is also a constant. It's 1. However, it's between minus W and W. So instead of minus infinity, it becomes minus W when we write what the value of each one. So it's just a constant. You integrate in between minus W and W, you get this. Now you want this to be equal to 15 watt. So W will be equal to, find W, which is this. So this is the value of the low pass filter, ideal low pass filter, such that the output power is 15. And you can think about different questions that can come out of the same source. Okay? So now, if we try to summarize what we have done in the random processes. So that it goes down. In the random processes, what we did is we introduced the concept of probability in chapter 1 with counting principles and how to count, how to find the probabilities, and what are the axioms of probabilities. And we talked about in the concept of conditional probability, the independence of chapter 1. And then chapter 2 we define the random variable, and we say, okay, we can just keep looking at the experiment, keep carrying it down, carrying with us the details of the experiment. Let's define a random variable that basically is a function of numbers. Here's the concept of random variable. We call it a distribution function, density function, recurrent. Back to chapter 3 and about operation in this random variable, functions of random variable, or moments. Chapter 4 and 5 was the same as chapter 2 and 3, however, for two random variables. And then we switched gears to random procedure, where basically when you run an experiment, you don't see an outcome, you see a waveform. Okay? And we said that in order to start this, we need the relationship between the random variables at different times. And we define the operation function, and we defined also the Gaussian random process and so on. And then chapter 7 was, okay, we studied the time domain analysis of in chapter 6. We talked about the frequency quantities of random procedures, in which we defined the random power spectral density. And the relation between the random power spectral density happens to be the frequency form of the operation function. And then we talked about in chapter 8, when you have a nuclear system excited by random process, the frequency characteristics and the time characteristics, and so on. And this basically ends the probability part of this course. Now, what's coming into the coming few classes is the statistics part. The statistics part, there's a reference. I already uploaded the reference. I send it to you, so you can just focus on the sections that we will cover. And before I start, we need to distinguish between the probability theory and the statistics. They are related, however, they are a little bit different. One leads to the other, and the other leads to the first. When we talk about random variables, very good Gaussian. And I tell you that your exam distribution, your exam grade distribution was a Gaussian. Right? And I tell you that you have a Gaussian variable with certain mean, كم تعرف الإنسان supposed to be, and the variance was مثلا 20. صح ولا لا؟ And we will go and find the probability that, for example, variable discussion, probability that x is this time 5, and so on with tables, right? And if I tell you that no, it's exponential, what is the parameter of the exponential number? And we go and find the probability is it will be the exponential. However, in real life, you really don't, you have data. You don't have a random variable with a given EDA. In real life, actually, as an engineer, how do you encounter randomness? You have a signal and you have a waveform, so you measure the waveform. You try to find how much is the range, what is the quality that it has. It goes between certain values and so on. Or you look at exams. You can go to grade for the class. Do you really have a distribution? Anybody gave you that it's Gaussian or not? أحد يعرف Gaussian or not? Nobody knows. What you know is the data. It's the list of scores from which you can estimate the average. You can estimate the variance. صح ولا لا؟ آخر شيء what we deal with is data. Engineers deal with data. And because we started the course with the concept of probability, and if I give you a distribution, a random variable, a system distribution managed with certain mean variance PDF, then you know how to find the different probabilities, right? However, who gave you the distribution with this mean and this variance? From it we did. In real life, you need to estimate these things. You need a way to estimate the mean. صح؟ من the way you have data at the end you have a set of data عندك اكسل شيت مليانه ارقام. الارقام هذه represent what؟ represent مثلا scores of students, high school students in class. طيب الارقام هذه موجوده في اكسل شيت. How do I use it? To find the average of the scores of students, to find the variance of the scores of students, to find even the distribution of the scores of the students. صح ولا لا؟ Okay, so in the statistics part, what we'll try to argue is we need, in order to use all the knowledge that we have done, we have learned in K-15, year distribution, probability, how to find, and so on and so forth. In order to be able to use this, we need ways to estimate the mean, with distribution combination. So what we will do here, we will try to also هنشرح what population mean, what sample size mean, what data set mean, ايش كل الاشياء اللي بتكلم عنها انا. And how to do some estimation of a specific value, specific characteristics of the distribution. And then we'll talk about another way to do it. So now let's start with some definitions. Definitions that hopefully will explain to you some of what was said. So a well-defined collection of objects is called population. ايش يعني؟ فنقول جامعة الدكتور. هذول population. سكان المملكة العربية السعودية هذول population. اوكي؟ المشتركين في اختبار قياس هذول population. Population means what? Means a large collection of people understand. Okay? الآن a sample, so this is a population is everybody. واضح؟ Everybody who took the exam, everybody in Italy, everybody in Saudi Arabia. This is the population. بينما the sample is a subset of the population. الشيء اللي أنا just trying to use to make estimation of whatever characteristics of the population. يعني مثلا انت الان عندك كيف يبين ستودنتس تبغى تشوف الافرج حق الطلاب كيف يبين. What you do is you try to get a sample of this of the number of students. Sample بدل ما تتكلم عن 10 قاعدة لا I will take only 100 students and or 200 students and I will do my study. ايش الستدي؟ I will try to estimate the average GPA, I will try to do the average graduation rate and so on. Why do we take a sample instead of the whole population? ايش رايكم؟ كيف يكون عندك اصلا access to population؟ سكان المملكة العربية السعودية تبغى تتكلم عن الهوايات. Do you have access لهوايات كل سكان المملكة العربية السعودية to study هواياتهم أو البلاد تايب أو whatever؟ ما. So in order to do this الناس ايش يسووا برا؟ يسووا سامبل طلعات الرأي. هاي سامبل من الناس طبعا لها شروط لازم تكون unbiased لازم تكون يعني في أماكن مختلفة and so on. So basically a sample is a subset. Why do we take subset? Because in many cases we don't have access to the whole population. And because of that we take a small sample and we do the analysis. Okay? في بعض الأحيان لا أنت you have access مثلا الرجستrar he has access to all students. So why take a sample? لكن في أماكن ثانية no you don't. في many applications you don't have really the access to the population, you only have an access to a sample. بس واضح الفرق بين الاثنين؟ النايم آخر شيء. طيب. So now this sample or population, it has some characteristics. Characteristics تنقسم إلى two different types of characteristics. صفات. Either categorical or the numerical. Categorical مثلا you can say that the gender of the population of the gender you have male. This is you can divide you have characteristics of the gender. Or you can have مثلا خلينا نتكلم عن طلاب الجامعة time specialization okay. Or you can have numerical مثلا age, height, so you can divide the population into categories according to either. So the characteristics of the population can be either categorical, like descriptive, or numerical like age مثلا above 50 below 20 الهايت اعلى من كده اقل من كده. واضح؟ So these are what we call characteristics of objects in the population. Now, a variable in any character of is any character a variable is any characteristics with a value that may change from one object to another. يعني مثلا كل هذه الاشياء الفاريبل مثلا الايج الهايت كل هذه variables. So, for example, population is undergraduate students and curriculum. Sample is students. Are selected based on their major. You can have students or no students above 3. Okay. Another sample. Variable X is major of the undergraduate. Y is the undergraduate and the age of the undergraduate. And you can have a third variable like age. Age is different variable. Major is a variable, and age is a variable. Is right. GPA is another variable, right? And so on.
Isn't this sample biased? Because we have the population under class theory.
Yeah, طبعا.
We only take
أنا أبغى أدرس الإي students. So whatever conclusions that I will draw, it will be only applied for E students. Like this is a sample. This is a sample. أنا ما قلت إنها unbiased sample. It's a sample. Like you can take another sample if you want to have a study that applies to SPOPM. You need to have a sample that is taken from many departments. Like in هذه الحالة, it's a sample. You can have a sample that is students with GPA above 2. Or GPA below 2, weak students. Nothing. All these are samples, valid samples. يقيسوا ايش؟ يقيسوا اشياء مختلفة. جواب واضح definition ذلك يعني بعد كده حنتكلم عنها عن يعني using them in many places. الآن if you have access to the whole population, then you can have a good knowledge about the distribution, خلينا نقول GPA, distribution of the GPA and so on. PDF صح ولا لا؟ لكن if you don't have access to the population, then what you can do is you can use a sample. بدل 10 I can use only 100 students and I will calculate the average GPA. The average GPA هذا ما حيكون هو الافريج حق البوبوليشن، حيكون الاستيميت. واضح شباب الفرق؟ The true average is the average of the whole population, which in many cases we don't have access to. Like an estimate of the average is the average of the sample that we have taken. So let's start with the average of the age. Can you go to every one height of ساعات العامة they know everything because they have الكاونت حق تعداد السكان كل مدة في 5 سنوات. لكن شخص بفضل يعني ما عنده اتصال بهيئة الإحصاء. What he can do is he can do some sample. He can find a sample of people and try to estimate the average age, estimate the average education, and how many years he studied after the 6 years, and so on.
ما يكون مثل ذاك وجدت فيه غير واقعي إذا تاخذ من 1000 شخص ولا أقارن بأفرج مليون شخص.
ممكن يكون بعيد مرة. So what we study here is how is this estimator close to the mean life when the sample size becomes large. Okay, this is what we try to find estimators that are good as the sample size becomes large. طيب great.
like a fixed percentage of the sample subset.
You need to have at least as the sample size becomes larger, the error becomes smaller. Okay. Like you don't need, in order to do estimation, you don't need a statistic size, sample size. Like this is another topic, which is the sampling. Sampling is related to how to choose a good sample. We will not discuss this. How to choose a good sample, it has certain conditions. That unbiased sample. It has, by sample size will give you certain error. زي ده من استطلاعات الرأي اللي كان يتابع مثلا انتخابات ترامب وبايدن، يقول لك استطلاعات الرأي يقول انه بايدن مثلا تقدم على ترامب كذا والايرور مارجن is 2%. الايرور مارجن وين يجي؟ من sample size. اوكي؟ تفضل.
ايش افضل لو اخذت مثلا 1000 for example student and did all the calculations in the 1000, or I took 100 10 times, and for each 100 I did a calculation for the data, and then I gathered all the data.
It should be the same. Should be the same. انت كأنك في combine with the same way, with the same way. طيب. So data set observations on a single. Now we zoom into variables. Data set is observations on a single variable or more simultaneously. Okay. Again, data set is measurement sample. So now you can have univariate data. Data set can have different variables or one variable. One variable, مثلا one variable هذه univariate معناها one variable either categorial or numerical data. Categorial اللي هي male وفيميل أو whatever. Numerical data certain numerics, age, GPA, whatever. Okay. Or you can have bivariate data. While you are collecting the data, you have for every point, for every person, you are collecting مثلا height and weight. So in this case, your data set contains pair of information for every point. For every person in Saudi Arabia, I'm collecting the height and his weight. So in this case, this is a bivariate. هنا لا، هنا I'm talking about either his gender أو مثلا وزنه. أو لو تلاحظ هذه ما لها علاقة بهذه. هنا لا bivariate. Height, weight. ممكن height, gender. ممكن connected مع بعض. The categorial and the or I can have multivariate, more than two variables. Like for example, in a medical school, they look at the systolic blood pressure, diastolic blood pressure, اللي هو اللي فوق واللي تحت، يقول لك 120 على 80, 150 على 60, 200 على اللي فوق واللي تحت, and the cholesterol level. So مثلا 120, 80, 170. This is a typical data point, one data point for one person. Well, so either we have a univariate, bivariate, or multivariate. So I will focus mainly on the univariate. طيب ايش inferential statistics? Inferential statistics is the science of collecting samples and make inference on certain variables. ايش يعني inference؟ استنتاج. Okay? So ده نتكلم عن مثلا average age في المملكة العربية السعودية. In order to be able to find the average age, simply you need to have access to the whole population, which nobody has except Riyadh. خلينا نقول انت عندك project, you need to find جزء من البروجكت حقك تبغى تدرس اشياء لها علاقة بالايج في توزيع العمر في المملكة. What do you do? At least you can do sample. You find a sample of people and try to you find a sample of people, a sample from the population, and perform techniques to make inference. Inference is يعني conclude استنتاجات about the population. هذه يسموها inferential statistics. Okay. So basically, what we do here in inferential statistics is the opposite of what we did in the probability. In the probability theory, we assume we have access to the population and we know everything in probability. So I know that it's exponential distribution with certain parameters and everything. بعد كده من هنا أقول والله okay, what is the probability that if I take a sample they will be larger than 5 or less than 2. كل المسائل اللي حليناها في البروبابيلتي صح ولا لا؟ How do I find the probability that the population is larger than 50 years old? By using the BDF and integrating the BDF from 50. صح؟ بس مين أعطاني الBDF هذه؟ I assume that I have population and everything that I know about the population. وهذا الكلام عادة هذا يجي من هنا. How did you assume? How did you do all this? Well, you did some statistics. You took a sample. The sample هذه you applied some statistical estimation techniques to estimate the mean, variance, even for the whole PDF. And then once you have this sample and you did all this, you assume that you have the population. And now for any new sample, you can use the PDF that you found to find that population. واضح الفكرة؟ So they are connected. What we studied, what we used all our time in this course is here. Assuming that we know everything about the population, everything معناها ايش؟ What do I know? How do I know everything about an experiment or population? Means that I know the PDF. صح ولا لا؟ Assume that I know the PDF, I can calculate what is the probability that specific sample of people are above this or below that, or whatever. صح? Assuming. How do I do this? How do I find these things? How do I get access to the population? Through samples. And I do inferential things. اللي هسويه في the rest of this class and the next two classes at least is how to find, how these techniques work. Some techniques. هتعلم at least two techniques. At least معناها إن شاء الله we'll be able to do. واضح شو الفكرة؟ الفرق بين اللي سويناه طول الكورس واللي هنسويه في ال next 2 or 3 lectures. طبعا the main or the most common inferential procedures are the point estimation by confidence interval, and hypothesis estimation. We will cover this for sure. The rest here a little bit. I'm not sure about it. We'll try to, at least, if we are not able to cover it, at least to give you the main ideas. Clear? طبعا قبل ما نبدا نتكلم عن what are the common techniques to do estimation, let's talk about أول شيء descriptive statistics. And descriptive means what? Means that I'm not really trying to estimate the mean or the average or the variance or whatever. No, I'm trying to classify the data. So a sample size n here is the number of observations. Okay. For the data set of n observations on variable x, the observations are x1, x2, x. مثلا خلينا نتكلم GPA حق students. I do not 100 students. And the GPAs of and the variable here is the GPA. So x1 is the GPA of the first student, x2 is the GPA of the second student. Assuming that no, I'm talking about the age. So x will represent the age of students, x1 will be the age of the first student, x2 will be the age of the second student. Now, if I plot the relative frequency of different observations value in a data set, relative frequency is what? Means that, okay, and I look at the GPA. Okay, GPA يبدأ من كم؟ خلينا نتكلم إنه 1.7 إلى 4 صح؟ أشوف أنا كم واحد جاب هذه، كم واحد جاب هذه، كم واحد جاب هذا GPA، كم واحد جاب هذا GPA، كم واحد جاب هذا GPA. واضح؟ This is the histogram, is the distribution or it shows the relative frequency of students who got this GPA x1, this GPA x2, this GPA x3. How many students got this? How many students got that in the sample? In 100 students, 20 جابوا هذا، 15 جابوا هذا الGPA، 2 جابوا هذا الGPA. Well, this is what we call histogram. Now, this histogram divides the data into classes. ممكن يكون unimodal. Unimodal means what? Means that مثل Gaussian. معظم population, معظم samples is concentrated around certain value. وبعيد عن الفاليو، كل ما تبعد عن المين هذه المين value, the distribution, the histogram decays. Or it can be bimodal, means that والله فيهم مركزين هنا وهنا. So some of most of students are concentrated around this value, and the other, or half of them here and half of them here. Okay. يعني خلينا نتكلم عن الجندر. تلاقي مثلا if you look at the sample of all male, تلاقي مثلا الage الويت الهايت حقهم it has an average، بعدين يبدا يقل عدد الناس اللي اصغر من الافرج، يقل عدد الناس اللي اكثر منه، صح؟ فيتكلم الافرج 170 سم 165 سم. بينما if you are mixing نفس الشيء لو يكونوا بنات. بينما if you are mixing الأولاد مع البنات السامبل زين حتلاقي إنه والله السامبل هذه جزء منها طول البنات جزء منها طول الأولاد. عادة طول الأولاد أكثر من طول البنات. تلاقيهم concentrated here and here. You can have it, so basically this is in terms of model. Model means either it has one focus or two focus areas. Or you can have skewed, positive skewness or negative skewed. هل هم to the left of the knee or to the right of the knee, most of the population. هذا يسميه descriptive. Until now we did not do any estimation. We only try to understand the shape of the histogram. We try to describe the shape of the histogram. طيب. الآن if I have certain sample and I would like to find the mean of the sample. I need sample mean. Okay? ايش تسوي؟ إذا أنا أعطيتك مجموعة أرقام ages of students ولا GPA of students, how to find the average? I add them and I divide by their number, صح? So basically, the arithmetic average of a sample is simply the summation divided by 1/n. Okay? One has measures the location, the center of the sample. And if you have the samples with some outliers, then this average will be ايش يعني outliers? Means that في عندك بعض السامبلز قريبين من بعض، في سامبل جاي هنا. And either caused by an error, measurement error, or واحد ما شاء الله مثلا طويل ولا سليم هاي جزئية، ولا واحد very low. واحد جاب مثلا 3 من 100 في اختبار والباقيين معظمهم من 50 ل 80. ال 3 من 100 هذا يعتبر ايش نسميه؟ outlier. يعني أثر على الافريج، لكن احتمال كبير انه he will drop. So at the end everything will converge. So this sample mean in general is sensitive to outlier. The population mean هذا هو اللي سميناه X bar. هذا عبارة عن ايش؟ Expected value of X لك. هذا you assume انك you have access to the PDF, صح؟ You assume that you know everything about the population. Now this is the true mean of the whole population, which in general you don't have access to. نتكلم عن الأشياء اللي علاقة بدولة كاملة. Usually you don't have access to. What you can do is to estimate it. Like this. Now how to estimate it? الأفريج هذا قلنا هذا estimate. Okay, fine. لكن في أشياء ثانية ممكن تكون معقدة أكثر. ما هي بالسهولة. الأفريج is easy to estimate. لكن other than average, it might be difficult to estimate. يعني مثلا أعطيكم examples. أنا أقول لك إنه أوكي جالسين نجمع داتا، الداتا هذه تعطينا هيستوجرام شكله كأنه كذا. اوكي، هيستوجرام شكله كأنه كذا، لكن مو واضح كذا، في بعض الأشياء هنا، يعني السامبلز جاية كذا مشخبطة هنا وهنا وهنا وهنا، لكن في بعض الأشياء outliers. How to estimate this point اللي هي limit of the uniform distribution. هل هي 10 هل هي 5 هل هي 3؟ إذا قلت إن هي الماكسيمم this is an estimate، صح؟ خلينا نقول إن أنا عندي داتا، قلت والله هذه الماكسيمم هي تعرف اليونيفورم distribution from 0 to b. What is this b? We don't know. You need to estimate this b. واضح؟ and different examples. مثلا Gaussian distribution. جينا حسبنا، جينا شفنا هيستوجرام شكله قريب من هذا. What is the average? You need to estimate the average. قلنا الافريج هذا واحد استيميتر. Might be good, it might be bad. نتكلم الآن عن properties of estimators. Okay, so we need to distinguish. أنا هذا السلايد مهمة. Sample mean والpopulation mean. إيش الفرق بينهم يا شباب؟ إيش الفرق بينهم؟ This is the true average. This is the ultimate average of everybody. بينما هذه only of that sample. لو تاخذ sample ثاني يطلع لك different. Exactly. Thank you. تفضل.
When you calculate the average method, use the population.
In general, زي ما قلت لك الريجستrar عندنا he has access to everything in the intake again. So why to use samples؟ لكن إذا أنت طالب أو دكتور أعطوه كوميتي معينة قالوا له أوكي سوي لنا ستدي على كذا كذا ما عنده everything. He doesn't have the full access. So at best he can do sample of students. مثلا ياخذ مثلا مجموعة كلها تاخذ مجموعة كلها كذا 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 ويسوي سرعة. So in general, if you have access to the population, why to do sampling? But in many cases, you don't have access to the population. So the sample mean changes from one sample to another sample. Whenever population mean is the ultimate mean, is the true mean, which we don't have access. We need to estimate it using the samples. So every time we do the sample, every time we measure the sample mean, we get certain sample mean, right? So basically you expect that every time you measure the sample mean, you get a different sample mean. So the deviation, so if this is the true mean, this is the true mean, the population mean, and these are the samples, x1, x2, x3. Now, how far these samples from the mean will affect your estimation? Then we will على outliers. And in order to calculate this, we need to calculate what we call the sample variance. What is sample variance? Sample variance عبارة عن these readings, these sample points, minus the sample mean squared divided by n not all, n minus 1. Why do we divide by n minus 1, not n? هنتكلم عنها حاجة اسمها related to unbiased estimator. So if we have sample means, in order to find how the samples away from the قياس exams, you have the average and the variance. Your exams, you have the average and the standard deviation, the square root of the variance. How to calculate the variance? ما عندي access to the variance. Do I have access to the variance? The true variance, the population variance? I don't. So the best is to use the samples that I measured, n1 of n samples, to find the sample variance. How to do that? By taking every sample minus what I measured, the mean, the sample mean, and take a square divided by n. So this is here is the sample, and the true mean. This is the sample mean that we measured in the previous slide. Not x, because I don't have access to it. As also I don't have access to the variance. So my standard deviation, sample standard deviation is S, which is square root of S. Again, population variance is this, which we don't have access. We don't. Unknown to be estimated. We don't know it. If I know it, I will not do all this. I have a stream of data. I have an Excel file full of numbers. I need to find the population variance. How to find it? By estimating it using a sample. So next class, what we'll do is try to talk about more examples and to talk mainly on what are the properties of estimators, different estimators, and how to choose the best one. I'll take an example on for the mean different estimators exist. For the uniform distribution and different estimators exist. Which one is the best? We'll talk about it next time. Thank you, Shubham.